Okay. Let's start today class. Good afternoon, everybody. Good afternoon. How are you doing today? How are you doing? Good. Okay. This side of the class, just I think that they are so tired. I cannot hear from this side. Okay, let's start today class. Please answer these two questions. Show me how much you studied previous lecture. First question needs a little calculation. The second one is the easy. You can answer it in 2 seconds. First question is 1 minute. I will give you 3 minutes. Did you answer the questions? No. Can I show the result? Yes. Are you confident to your answers? No. Let's see. Can I show the results? $40 and 60%. Total is 100%. The first question, less than half of the class answered correctly. Second question, 60%. Answer it correctly. Now, go back to the questions. First question, a 10-pound particle has a force of F bond 3I plus 5J and F2 minus 7I plus 9J acting on it. Determine the acceleration of the particle. Wait, I forgot. No. Now, to solve the first problem, there's a particle look like this. F1 3I plus 5J. This force. Exactly if you draw this vector, it looks like this. And F2 is look like this. Applied to the particle. Now we want to find the acceleration of the particle. To find the acceleration, we need to use the equation of the motion. Sigma F equal to ma. This is the vector form of the equation. Now, left-hand side is a vector, summation of the vector of all external forces equal to mass multiplied by acceleration. Now, if these are the two forces, this one is sigma F, horizontal force. Means that we need to add these two vectors equal to ma. F1 is 3I plus 5J plus minus 7I plus 9J equal to mass. What is the mass of the particle? How much is the mass? 10? 10? No. It's the weight of the particles, not the mass. If I just want to mention the mass, I just mention here 10's law. It's a weight. This is the point. 10 divided by 32.2 is the mass of this. I divide by g, gravitational acceleration. Multiply by acceleration. Now, if I add these two vectors, minus 4I plus 14J, as some of you find this and selected this one, some of you just divided by 10 and find this one. But this one is this, and to find the acceleration is minus 4 divided by 10 over 32.2 I plus 14J divided by 32.2. Sorry. (10 divided by 32.2). If you calculate this one, it is approximately 12.9 minus. If you calculate this one, it is 45. The correct answer is C, as 40% of you answering correct. Got it? Yes? Okay. Any questions? No? Yes?
Why'd you divide by 32.2 instead of multiplying by?
Just because the weight is mg. The weight is 10 equal to m multiplied by 32.2. The mass will be 10 over 32.2.
Thank you.
Slot.
Thank you.
Correct. Questions? No? Okay. First question, the answer is C. The second one, that's the easy one. If a particle is connected to the string, the elastic spring force, it is expressed by F equal Ks. S is in this equation is this C. The difference between deformed and undeformed lengths. Not the initial one, not the undeformed one, and not the deformed. And also it's not a spring constant. Got it? Okay. Now, any questions? Any question from previous lecture? For the homework that I gave to you, and also the deadline will be tonight, 3 questions. You need to use the equation of the motion in rectangular coordinate system. Similar problem I gave you in the practical example. For this last question, I exactly solved in the class, but there's a little difference. There's a little difference. You need to just read the problem how I solved and rewrite and replace one number and recalculate. Any questions? Yes?
When are you going to post the notes from last lecture?
I posted today. The reason I didn't post, I just used this computer to for the internet problem. They just told me that I cannot use because of the wireless. This one is a LAN. This one is much better. I just put this files on this one. I forgot to copy to my USB drive. That's the reason. Okay. Today I access the files. I will put those ones today. Great. Okay. Or might be during the break time. Okay. Now, the last part of the equation of the motion is in the cylindrical coordinate system, the last coordinate. For this coordinate, we want to analyze the kinetics of the particle using cylindrical coordinate. And you'll see some applications, how we can develop the equation of the motion for a cylindrical coordinate system. And also, I will explain how to solve the problem and show you one angle between radial and tangential directions, but this angle is called. You will see different applications. For example, arm of robot, or this one, special disorientation trainer. These two ones is an example to use to see how much forces is applied, for example, to this small circle, small ball, or for the people who are sitting in this cabin. We want to see how much forces is applied along R, along the theta, and also along the Z directions. This type of trainers is used for some pilots wants to use for helicopters, or they will use for simulating the wing when it's just vibrating, and others. These are 2 applications, and also more applications. Most of them, as you can see, they will use on the mechanisms. Okay. Now, if you remember, and also that was a question for the quiz, that, for example, to show the radial and transverse coordinate system, if this R shows the position, if I extend this direction outward, this will call R axis. Perpendicular to this direction, it is called theta, or transverse axis. It is positive in counterclockwise direction. In previous lecture, you learn about how to find the velocity along the R, velocity along theta, acceleration along the R, and acceleration along the theta in previous chapter. Now, in this chapter, I want to show you, for example, for this arm, if you want to see how much force is applied to this small ball or small particle, small object, how much is it? Or for different r and different theta, or different angular velocity or different angular acceleration, does this f theta will be changed or not? For example, your robot that you design is holding glass. You do not want to just glass fracture or crack it because the force is limited. Or for this type of mechanisms, if this mechanism wants to just rotate about this point O, you want to see how much force is needed for different theta, different r, different angular velocity, different angular accelerations. These are some of the examples, or this mechanism. This is a straight held follower with the cam rotating. Now, to find these forces and to relate these forces with the acceleration along the theta, we need to use the equation of the motion. The equation of the motion, as you saw and also review today, this is an equation of the motion in vector form. Now I want to develop and expand this equation for a cylindrical coordinate system and relate the forces along theta and r with the acceleration along r and theta. First, this is from section chapter 13, section 6 of the Hibbeler book. And also you can find this one in the chapter 3 of the Merriam. First, this method to using the cylindrical coordinate system. Cylindrical coordinate system, we use r, theta, and z for the 3D. And we will use r and theta for a 2D problem. This one is called polar coordinate. Why we need to use the cylindrical coordinate system? Because sometimes the problem or the motion you want to solve is more complex. And also, it is better described using cylindrical coordinate system. As you can see on this applications, it is better to use the polar coordinate system. Why? There are r and theta on all of this one. If you look at all this ones, it's the position can be found using r and theta, and also using theta dot and theta double dots. Now, to use this one, and as I explained, we will use the equation of the motion in the vector form, and for a particle in a 2D, as you can see. If I divide the left-hand side of this equation into components along r and theta, and also if I divide the a, or the acceleration along the components along r and theta, if I substitute into this equation and equal the component along the r, or component along r, component along theta, and component along the z, we can find these three equations. What are these three equations? These three equations, they are similar if you just compare with the equation of the motion along the x. It was sigma fx equal max, sigma fy equal may, and sigma fz equal to maz. This is in xyz coordinate system. Also, in normal, tangential, and binormal direction, we found this equation, sigma Fn equal MAN, sigma Ft equal to MAT, and sigma Fb equal to 0. These three equations are the equation of the motion in r, theta, and z direction. You will see just the index for this. Instead of x, just use n. Instead of n, you use r. These are similar, but in different coordinate systems. And I substitute the acceleration along the r, acceleration along the theta, and acceleration along the z. You learned it in previous chapter. This is nothing new for you. And this is equal, for example, the acceleration along the r, or radial acceleration. It is r double dot minus r theta dot square. Theta dot square, it is the angular velocity. Theta double dot, it is angular acceleration. And r double dot, it is the second derivative of the r with respect to time scores. Now, question. What is r double dot called? Yes?
Is it angular position?
No. This is not position. It's the second derivative of the position. What is the second derivative of the position is called? Yes, acceleration. This is kind of called a linear acceleration. Also, you will see that if you just check the units on the left-hand side and the right-hand side of this one. Look, left-hand side is the Newton. Also, m r double dot is a kind of m multiplied. This one should be an acceleration. Or for the next one, r theta the square, this one also has a kind of some type of acceleration units. And also in here, r dot is the derivative of the r. With respect to time, this one is a type of velocity or linear velocity. Now, to use these equations in the cylindrical coordinate system, first step, we need to first draw the free body diagram. Why? If you can see on the left-hand side of these equations, there are forces along r, theta, and z. We need to see what type of forces are along r, what type of forces are along theta, what are along the z direction. The right-hand side of this equation is easy, just it's a calculation, mathematical calculation. You need to find the derivatives or some of the value is given, such as angular velocity, angular acceleration, r dot. For r, when it's given to you, you can find the derivative of the r or the second derivative of the r. In my opinion, this part is the easiest, okay, because it needs calculation. And you just need to use your mathematical knowledge to find the right-hand side of this equation. But left-hand side of this equation needs a free body diagram. You know how to draw a free body diagram, but you do not know how to draw a free body diagram for a curvilinear motion when you want to use the cylindrical coordinate system. Now, to show how to draw the forces, can I move to the next slide? Any questions? No. To use, and also to show the forces along tangential and normal forces. And this first, this one is the particle. It's moving along the curve. The equation of the curve is given is path. The blue one is the path of the motion. Now, first, this P is a type of applied force, pushing this one to move. Okay? Now I want to just show you what is the direction of normal force and what is the direction of the frictional force. If I draw a tangent line, look, if I draw this red line, that's a tangent line. The normal force, it is perpendicular to the tangent line. Also, the frictional force will be along the tangent line, but in opposite direction of the motion. I will give you a hint to remember and also see that this is consistent also for other motions. Do you remember the rectilinear motion? First session, I explained about the rectilinear motion. It's a motion of the particle. It's moving along straight paths. Now, if this box or this particle is moving along straight paths, just moving on along a straight one. Now, also, this line can be the tangent line. It's tangent to the path of the motion. If I ask you to draw the normal force, how do you draw the normal force? How? What's the direction of normal force? What? In this one, if I want to draw the normal force, what's the direction? Yes. Perpendicular to tangent. Also, in here, I just mentioned normal is perpendicular to the tangent. This is consistent with this. If you do not remember how to draw this one, just draw this one. It's a kind of basic one. Normal force will be perpendicular in this direction. It is perpendicular to tangent line. Also, if this one moving from left to the right and ask you to draw the frictional force, how do you draw the frictional force? How do you draw the friction? Yes?
It's perpendicular to the normal force.
Perpendicular to normal force. Or it's along the tangent line in opposite direction of the motion. Here, this will be the frictional force. Now, you will see that the frictional force is along the tangent line, but in opposite direction of the motion. Similar to this one, this F, or I just used F. Frictional force. Maybe some of you use another notations. This is the frictional force. Exactly. In opposite direction of the motion. Or in the tangent line, but opposite direction of the motion. This is about normal force, frictional force, and the P. Now, if I draw the radial axis, this is the radial axis. Also, if I draw the theta axis, first, you will see that, guys, tangent line is different from theta, different from R. And also, this normal force It is not along r, it is not along theta. If I want to use this equation, sigma fr equal mar, sigma f theta equal to ma theta, I need to find the forces along the r and theta. To find the forces along r and theta, I need to find this angle. For example, if I have this angle, the n cosine theta will be along the r, and n sine theta will be along the theta. Now, how we can find this angle? I want to explain another terminology. We use a sine. Let me erase this. Psi, this is the angle between the radial axis and tangent axis, or this. This angle is psi. How we can find this one, I will explain next slide. But if this angle is psi, how much is theta? If we know the psi, how can I find the theta? Yes? Because n normal force is perpendicular to the tangent line, this angle will be 90 minus psi. This is the reason we need to find this psi. If I have the psi, I can find the theta. I can find the component of normal force along r and theta, and component of the frictional force along r and theta. You need those ones. Why? As I mentioned, sigma f equal to fr equal mar, sigma f theta equal to ma theta. Then, look guys, this part of the lecture I just emphasized and explained. There's one question in your exam. Based on my experiences in my previous students, at least 40%, they cannot solve this questions. Please pay attention. Each concept I just mentioned it here, when you go to the home, you cannot understand it. This is based on my experiences how to teach this one. What is this? What is this? And also I will solve 2 examples. Whole of this lecture will be go for this concept because it's important. You will see later. To find the psi, there's a one formula. This one, tangent psi equal to r divided by derivative of the r with respect to theta. This equation is usually given to you. The equation of the motion, for the equation of the path of the motion, is given to you. When you have this one, for example, r equal to 2 multiplied by theta. Theta is this angle. At this point, for example, you have theta, you have r, and you can relate r with 2 theta, for example. Now, how we can find the psi using this? Tangent psi equal to r 2 theta. The derivative of the r with respect to theta, it is 2. Tangent of the psi equal to theta. At different angles, you can relate psi with theta. For example, if you want to find the forces applied to this particle at theta of the 30 degree or pi over 6 radian, you need to plug in this one into this. Tangent of the psi equal to pi over 6. Psi will be tangent inverse of pi over 6. Most of the problem, it doesn't need to find this one. Using the geometric relations, you can find the psi easily, as I will show you in next 2 examples. But for some few problems, you need to find the psi. How much is this angle? You need to calculate it from similar to this and find the psi. Any questions? Now, can I move to the next slide? Oh. Before I start to solve, I want to give the recipe. That's how to solve this problem step by step. Okay? You need to follow these steps, then you can easily solve those problems. Now, for example, it's a particle. It's moving along a curved path. You want to use the polar coordinate system and use and show the forces and all things on this one. First step, for example, for this type of problem I will give you, you need to draw the radial axis r and theta axis. For example, this is the r showing the position and also using the theta angle. To draw r axis, this will be the r axis. And theta axis will be perpendicular to the r. Next, draw the tangent line. How to draw a tangent line? It's an easy one. Just draw a line that is tangent to this particle at this point. This is the tangent line. Next step, you need to draw free body diagram. To draw a free body diagram, these are the forces that you have to show in the free body diagram in this coordinate system. First one, normal force, frictional force, weight, and apply force. I use P to show this one is an apply force. Normal force, it is perpendicular to the tangent line. This is tangent line. This will be the normal force. Perpendicular to the tangent line. Next one is the frictional force. Frictional force, it is along the tangent line, but opposite direction of the motion. This one is moving this direction. If I want to draw frictional force is along the tangent line, but opposite direction of the motion. You will see that here, this is the direction they're moving counterclockwise, but frictional force will be in opposite direction. This is along tangent line, but opposite direction of the motion. The next one is the weight. How we can draw the weight? It depends. Why? Depends that this motion happens on a horizontal plane or it moves along a vertical line. For example, and here, at this example, this one is moving along the vertical plane. This screen or this one is a vertical one. When I mentioned that this motion happens in a horizontal plane, it looks like this. This is the motion, just to look like this. This is the vertical one. This is the horizontal. Now for the vertical plane, just you will see that this will look like this. And also, if I ask you to draw the weight, you will draw a kind of line in this direction. Means that for the vertical plane, we have the weight. And you just draw a line, look like this. That's it. If there's a motion in the horizontal plane, means that this mechanism or this motion is in the horizontal plane. This is the weight direction. The weight, it is not in this plane. Okay? Weight, if it's the motion is on horizontal plane, it is not in this plane. We do not need to draw the weight. Means that for horizontal plane, you do not need to draw, because the weight, it is not the plane of the motion. For the applied force, this one is the applied force. Applied force, sometimes it is given. If it's given, it's okay. Whatever is given, the direction and everything is given, and you do not need to consider, you just don't need to just put it as it is in the sketch. But if not given, draw the P or applied force along theta direction. And in direction of the motion. Look, let me use. If I want to draw the P, this will be the P. It is along the theta, and also is parallel to the motion. Something is pushing this one to move along the curve. Then, when you found those ones, Sometimes, as I mentioned, most of the time, this angle, psi, you can calculate this one using the geometric relations, sine and cosine and those things. But if you cannot, you need to use the formula I just mentioned. Find psi from tangent psi equal to r divided by derivative of the r with respect to theta. Then when you have this psi, you can find the component of the normal force, the component of the weight along r and theta, and you need to use these equations. Sigma fr equal mar, sigma f theta equal to ma theta. These can be found from free body diagram. These are easy, just it's a calculation. And you can find the unknown. Most of the time, the unknown are the P and the normal force. You have to find for this type of examples, as you will see on the next one, to find the applied force and the normal force. Got it? Any questions? Then in next 15 or 20 minutes, I will solve this. This one is a 0.5 kilogram double collar. The mass of this and this one both together is 0.5. What is the double collar? First collar is just that the link is moving along that link, and another one is just that that moves along this circular path. This one is for this that move along this. This one is that this link just moving along this direction. It can freely slide on arm AB on the circular guide rod if the arm rotates with a constant angular velocity of 3 radians per second. We want to find the force of the arm exerts on the collar at the instant of 45 degrees, and the motion is in the horizontal. I will give you 1 or 2 minutes just if you want to write or just think. I want to start to solve this problem for you. Now, for this problem, it is given the mass of this both collars, this one and this one. It is 0.5 kilogram. It can freely slide. What does it mean? No friction. Can freely slide no friction. I like this type of expressions because it reduces the load of solving and drawing in the free body diagram. Then there's a constant angular velocity of 3 radian per second. How much will be the theta double dot? If theta dot is constant and it is 3 radian per second. Yes?
0.
0, correct. It is 0 radian per second squared. Now we want to find the force that arm exerts on the collar. Look. We are looking for to find this force. P. How much is this force I'm looking for to find? When theta, it is 45 degrees, and also motion is in a horizontal plane. What does it mean? When the motion it is in the horizontal plane, what we should consider, what we should not consider. Yes?
That means we can know the
What?
and that means we can know the
Sorry, to be honest, I cannot hear. There's a sound of this. Sorry. What we can consider?
That means we can ignore the
Correct. Hey, yes, exactly. Sorry, just this conditioner make a noise. Now, if it's on the horizontal plane, no weight. This problem is the simplest problem you can find in this area. Now to find the P, I need to draw the free body diagram. To draw the free body diagram, okay, copy this one. Bring this one here. How I draw a free body diagram for this? Make a big one. Look, this one shows the position of this point. If I extend R outward, this will be the radial. And also, theta axis will be perpendicular to the R. This is the direction of theta. Next one, I want to draw the tangent line. Here, it's a tangent line. This one is a tangent line. Then, I want to draw a free body diagram. To draw a free body diagram, I need to show these forces. Somewhere you can list normal force, frictional force, weight, and the applied force. Normal force, it is perpendicular to the tangent line. This is the normal force. Check. There is no friction. I like it. There is no weight. Yay. 2 out of 4 just we need to draw. And also, I need to draw the P, apply force. How? You will see that P is not given. If P is not given, you need to draw the P along the theta and in the direction of the motion. You will see that this direction and this direction are in same directions. Now, I draw this. The next step, you will see that along the theta, we have the force of the P. But the normal force, it has component along R and theta. To find the component, we need to find this angle, theta. Now, or let me just use another one not to confuse. Beta. I want to find this angle, the angle between normal force and this line. Why? If I find this one, I can project the normal force along R and find the normal force along the theta. My question, how much is beta? How much is beta? If this is a motion and this angle is 45 degrees. How much is beta? How much? 45. 45. Other students, do you agree? How? 90 degree. 90 degree angle. This is 90 degree.
No, wait. Sorry. It makes the right triangle.
Yes. Now, if you look at here, if you look this triangle, this angle is 45, this one is 90. We can find beta is 45. Now, if beta is 45, means that normal force has one component along the R, it is n cosine 45, and also one component along the theta, it is n sine 45. This one, it is n sine 45. Now, we draw a free body diagram, R theta, tangent line, and now, in my opinion, we can solve the remaining easily. To solve this one, we will use the equation of the motion. Sigma F along R equal MAR. Sigma F theta equal to MA theta. You know those equations. Then, left-hand side, we want to find the forces along the R. What type of, how many forces that along the R? Now, what is the force along the R? What? Which force is along the R? N? How much, sorry? R component of the norm. Yes. It's n cosine 45 along the R. Along the theta, it is P plus n sine 45. Now, this one is equal to mass multiplied by acceleration along the normal. This is equation r double dot minus r theta the square. Also, acceleration along the theta equal to r theta double dot plus 2r dot theta dot. Now, for this one, we do not have normal force. We have this, we have this, we have this, but we need to calculate it this way. Next slide, I want to calculate those numbers. Can I move to the next slide? No. Wait. Yes. Which one? This one, let me see. This one is minus. No, I do not think so. This, let me see. This. Okay, let me just correct. This should be here positive. And also this one, the next one is correct. Thank you. This should be positive. Now, to find the R double dots and R dot, I want to go next slide. Make a clear note for you. I can write in here, but you cannot read later. R, it is equal to, look, R is given 0.8 cosine theta. Some of you mentioned how we can find is 0.5 cosine theta. At angle of 45, 0.8 cosine of 45 degree. If we calculate it, we can find the R 0.5657 meter. Then R dot is the derivative of the R with respect to time. Means that the derivative of 0.8 cosine theta with respect to time. This, to find this one, we need to use the chain rule. Why? This is the function of theta. To find this, we will write this one look like this. The derivative of 0.8 cosine theta with respect to theta multiplied by derivative of theta with respect to time. Then this one will be minus 0.8 sine theta. This one will be theta dot, or this is minus 0.8 sine theta, theta dots. Now, we have the theta, sine 45. We have the theta dot. If you go to the problem, theta dot it is 3. If you calculated R dots, will be minus 1.6971 meter per second. Then R double dot will be the derivative of R dot with respect to time. I saw a few students that just they plug in this one into this and take the derivative. This is not correct. You need to take the derivative of expression, not the final. Do not do. It's a common mistake. You have to find the derivative of this expression, minus 0.8 sine theta, theta dot, with respect to time. To find this one, I bring this one out of this derivation, minus 0.8. Then I will use the product rule. Means that the derivative of the sine theta with respect to time multiply theta dot plus the derivative of theta dot with respect to time multiplied by sine theta. Derivative of first term multiply second term plus derivative of second term multiply first term. Then this, if you use the chain rule, will be theta dot cosine theta. Or this one is equal to minus 0.8 cosine theta, theta dot square plus theta double dot sine theta. If you plug in the values in here, theta double dot will be 0. Theta dot is 3. This one is 45. If you plug in and calculate R double dot will be minus 5.091 meter per second square. Now we have R double dot. We will return back previous slide. Can I move to next previous one? Yes. Now, here I will write it for you. R, it is 0.5657 meter. R dot, it is minus 1.6971 meter per second. R double dot, it is minus 5.091 meter per second square. How I found those ones? Next slide. Now I substitute. And cosine 45 equal mass 0.5 R double dot minus 5.091 minus R 0.5657 multiplied by theta dot 3 square. From this, you can find the normal force. If you calculate it, normal force will be minus 7.20 Newton. What does it mean? It means that the direction of the normal force that I consider, it will be in opposite direction. Why I found this one minus. If this question it comes to your mind, which one is the correct direction when you want to draw normal force? If you just put, as I did in here, you will find a negative one. That's just, you need to change the direction. Now we have the normal force. From this equation, if we write this one, P plus normal force of minus 7.20 sine 45 equal to mass of the 0.5 multiplied by, the first term is 0, why? This is 0, plus 2 times of the R dot minus 1.69 6971 multiplied by theta dot of the 3. You can find the P. If you calculate this, P will be approximately 0 Newton. It's too small. It is 0.001 or something. I just round up. Now, any questions? No questions? If you do not have questions, let's have 5 minutes break. Professor? Yes. I forgot to grab my exam. question? Any question? For your homework, I will change only one word of this problem. What do you think that I will change? What? Vertical. Yes. For one of the questions in your homework, I will change only motion it is in vertical. That's it. Then, next question. Can you solve this one? There is a, we can solve it. There is a 0.5 pound rod guided along the vertical circular path. If the arm has angular velocity and angular acceleration, and at the instant shown, there is no friction, we consider the ball as a particle, then at RC equals 0.4 foot, we want to find the forces that apply to this ball. Let's start to solve. The weight of the ball is 0.5 pounds. Now, we can find the mass equal to mg, or equal to mass multiplied by 32.2. If you find this, the mass of this will be 0.5 divided by 32.2. This will be 0.016, and the unit is slot. Why I need the mass? We need to put it into equation of the motion. Now, it is along the vertical circular path. Vertical circular path. What does it mean? We should consider the weight or not?
Yes.
Yes. We have the weight. Theta dot, it is 0.4. Theta double dot, it is 0.8 radian per second squared. At the instant of theta equal to 30 degree, we want to find the force of the P applied on this ball. There is no friction. And also, we neglect the size of the ball, and it's a particle. Now you will see that in this problem, we have theta r. We need to use the polar coordinate system. To solve this problem using the equation of the motion, we need to draw the free body diagram first. Can you move to the next slide? I just made a big one. For this one, starting, this will be the r-axis. This will be the theta axis. And this is the tangent line. Then I need to draw this forces: normal, weight, frictional force, and the applied force. Normal force will be this. This is the normal force. It is perpendicular to the tangent line. Then we have the weight. To draw the weight, just draw a weight look like this. Just draw a vertical line in your paper. Weight, it is downward parallel to the vertical line. And there's no friction. And the applied force direction is not given. You need to draw the applied force direction. How? Applied force will be along the theta and direction of the motion. This is P. Now you will see that only P is in theta axis, but normal force and the weight both have component along r and theta. We need to find their component along the r and theta. Now, if I find this angle, again, if I call this angle beta, now, and this angle, it is 30 degrees. How much is beta? From here to here is RC. Yes. Why? Exactly. The beta will be 30 degrees because from this triangle, this length and this length are equal. These are both the radius of the semicircle. When this angle is 30 degree, this angle also will be 30 degree. Now, can I move to the next slide? Yes. Any questions until now? I just draw r theta, normal force weight, no frictional force, apply force along theta, found the angle of between n and the r. Then next one, I want to use the equation of the motion. Yes?
Just a quick question. For any problems where we get let's say theta on a given angle, I'm assuming that just would mean that majority of the time theta is equal to theta, right?
Right. Yes.
Okay.
For some of the problems, you will see that this and also, I want to give you one problem, or I will give you a practical example that we need to find the angle of the normal force using the sine relation. Okay. Most of the time, you can find from this relation, but versus so it's actually zero. Okay. Now, because most of the time, for example, sometimes it's different angles, and we therefore some of the problem always not moving along the circular paths. You can move along the whole paths. Okay. If I jump to the complex one, we do not like to solve the problems. Now, this is I want to use the equation of the motion along R, equation of the motion on the theta. This is equal to mass multiply R double dot minus R theta dot square. This is equal to mass multiplied by R theta double dot plus 2R dot theta dot. Now, left-hand side of this equation, we need to find the forces along the R and forces along the theta direction. For the previous one, bring this small version of this here for your reference. Now, along the R, if this is the ball I just mentioned, and this is R, this is theta. In one of graph, I want to show the forces along the R. In one graph, I want to show the forces along the theta. The forces along the R, you will see that normal force has one component along the R. It is N cosine 30. Also, the angle of the weight with the theta also will be 30 degree. And the component of the weight also will be W sine 30. These are two forces along the R. Along the theta, it's a particle. This is R. This is theta. We have N sine 30 we have the force of the P and W cosine 30. These are three forces along the theta. Two forces along the R, three forces along the theta. Why? You will see that this one is an extra, while P is only in theta direction. That's true, that's true. 2 times plus. Now, left hand side, it is n cosine 30, it is in positive direction, minus W sine 30, it is in negative direction of the R, equal to mass R double dot minus R theta dot square. Also along the theta, it is P plus n sine 30 minus W cosine 30 equal to mass multiply R theta double dot plus 2R dot theta dot. Now, just we found the left-hand side of the equations. We need to calculate the R, R dot, and R double dot for the right hand of this equation. Okay, move to the next slide. Then, R it is 2RC cosine theta, or 2 multiplied by 0.4 cosine theta. Or at the theta of the pi over 3, because we mentioned that we need to find the motion at this specific angle. 0.8 cosine of the pi over 3, pi over 6, sorry. If you calculate this, it will be 0.69. Now, all students, please solve R dot. Please, all of you. Yes. As a constant, because the radius of this is given. Calculate the R dot. I have the number in here. Everybody calculate. How much is R dot? How much?
-0.16 per second.
0.21.
-0.16
Do you agree? Other students, did you find similar, same, or different one? Do you confirm the number? Yes. Yes. Negative 24. R dot will be minus 0.16. To find this, R dot will be the derivative of the 0.8 cosine theta with respect to time, that this will be the 0.8 derivative of cosine theta with respect to time, that this one will be minus theta dot sine theta. If you calculate this, also, if you calculate R double dot, this one is similar to what I solved in the previous example. You need to use the product rule first, then use the chain rule. If you do that one, R double dot also will be, let me write the final equation. If you calculate this one, R double dot also will be minus 0.43 foot per second square. Now, please practice this one at home. All of you, practice this one at home. Why? For example, you cannot find this one correct. Okay? There's a 1 point minus at least. Then if you put in here, this acceleration will be incorrect, minus 1. Then you will find the normal force incorrect, minus 1. Then you put this one into this one, minus 1. You will find the P incorrect number, minus 1. At least 5 points out of 20 with one small mistake. This is my experiences from my previous students. They cannot find R dot and R double dot for the problems. Put those numbers in here, and finally they will find some numbers that's not correct. This is the reason I asked all of you, do this ones in the home. Practice with the homeworks. Okay? Each semester I will tell my two students to practice. Most of the students listen. However, I will see at the exam this problem and this issue happens again, and again. There is a false loop. Practice, please. I'm not like those professors just put the only final numbers in the slide. I do not like it myself. Okay, this at this slide at least I spent 10 minutes. I can just save this 10 minutes and teach other ones or solve another one. But this one is important, in my opinion. Some of you mentioned, some of you in your comments, just the details in the mathematics. We are not interested. We know those ones, but some of you, you do not know. That's the reason I have to write those ones. Please practice it. This one is important. Now, from previous slide, I found these numbers. R equal to 0.69 foot. R dot equal minus 0.16 foot per second. R double dot, it is minus 0.43 foot per second square. This is coming from next slide. Then substitute the values. N cosine 30 minus the weight 0.5 sine 30 equal to 0.016 R double dot minus 0.43 minus R 0.69 theta dot, it is 0.4 square. If you calculate N normal force, you can find the normal force 0.279 pound. Also, in this one, if I substitute normal force in here, P plus 0.27 sine 30 minus 0.5 cosine 30 equal to mass 0.016 or 0.69 theta double dot will be 0.8 plus 2r dot minus 0.16 theta dot also will be 0.4. Here we have one unknown. If you calculate this, you can find a P. It is equal to 0.3 pound. This is the answer I'm looking for. Any questions? Yes. Yeah. This one?
Yeah.
Yes. For the P is 0.3. Practice at home. Any questions? Can I move to next slide? Yes.
Go back to that.
Go back. Yes.
With the weight, could you explain the 30 degrees again for the heat?
Just these are the relation. This is perpendicular to this one, and this angle is 30 degrees. This is with this one. There's some relation between this. Here is perpendicular to this one, and this angle will be 60 degrees. This angle will be 60 degrees, and this will be 30 degrees.
Thank you.
Any questions? Any question, guys? Yes.
I'm really struggling with R double dot.
Well, okay. Any questions? Now, one concept, and then we will go home. In this slide, we want to find the work of the force. You know this one from the physics, but we want to find the work of the force for different forces and how to use the conservation of the energy. What is the principle of the work and energy? Some of those concepts you know in the physics, but I will show you in different forms. There are some applications why we need to find the work. If you want to just load this a crane, you want to just move and lift this heavy load, we want to know how much work is needed, how much is the work of the motor is needed, or what's the work of the spring and shock absorbers, or in impact and collision analysis, how much work or energy absorbed, for example, during an accident, for example. Or what's the work of the pumping system goals, or in different applications in aerospace, biomechanics, and energy. We want to find the work energy in different systems, in rockets, in tanks, and also in turbines. Then, one simple question. How do you define the work? Do you know this one from physics? Yes. Force times distance. Yeah. My question. Yes, it's correct. But, for example, if this one is the box, this one is moving in this direction. If I apply force in this direction, this force can do a work. Yeah. Means that not every work, every forces can do the work. Okay? What type of forces? This concept is just, you know, the work from the physics is force multiplied by displacement. I know. But in the dynamic, I will define the work. I use the notation U as for the work. Because in this reference, we use W to show the weight. To not to confuse with this one, we use U. But I know, maybe you use different forces, different notations to show the work. Whatever you use it, just stick to those ones. But I want to follow the references. Now, the definition for the work is the force dot dr, that's a differential displacement. Means that we do the dot product of two vectors. The dot product of two vectors, for example, if I have the vector A and vector B, what is the dot product of these two vectors? I think that most of you are tired. Okay, let's stop the course. Just use lots of your mind. Okay, please practice those examples. And also I will put the practical example in the Blackboard to just solve those ones. And we will continue this lecture for the next session. Okay? Thank you for coming to class. Have a wonderful weekend.